uh, you can start the session. That's it, sir. Are you there? You can start the session.
Dr. Sanjay sir, I can't find the seat sir here in the people list.
Okay. So in that case, I can start.
Yes, sir, go ahead.
Now, Darcy sir is in the meeting. Darcy sir, now you can start the.
Okay, sir. Shall we start?
Yeah. You can
Okay, sir.
start, sir.
So, good afternoon, all. Welcomes you all in the AIP second talk. Earlier, we have the first talk on based on the basic physics, and it was enlightened by many physics, and it was given by our professor. Now, I would like to invite the founder president of AIP, Association of Indian Physicists, Dr. Sanjay Kumar Singh. Sir is currently working as assistant professor at SD College, Barnala, Punjab. Sir has many academic as well as research outcomes. So over to you, sir.
Yeah, thank you, Darcy sir. Thank you so much. So, on the behalf of Janardhan Singh Foundation and Association of Indian Physicists, AIB, I, Dr. Sanjay Kumar Singh, Foundation founder president of AIB, heartily welcome Dr. Captain Rituraj Singh, President of AIB Central Council, who will chair the today's session, and Speaker Dr. P. Deepak, who is Vice President of AIB Central Council, or today speaker, and other council members and members of AIB faculty and B.Sc scholars, students from all over the India. Thank you so much to join today's talk on perspective of physics. I would like to give a brief introduction about our initiative. May I request Anki sir to present second slide. So, the objective of our association, as you know, from the social platform, that is, our objective is to do for youth and young teachers of nation who is highly motivated in physics to make great nation teaching various activities in university, colleges, and schools. So basically, what we will do to this association, we can provide talks, seminars, conferences, research-oriented meetings, discussion, presentation. Even we can provide debates, laboratory workshops, and competitions for teachers as well as students. Next, please. So the Association of Indian Physicists is a subdivision of the Janardhan Singh Foundation. That is basically this foundation, which has been registered under M.Sc, Government of India. Its branch office is in Barnala, Punjab, which have two office bearers. So this AIP organization consists of physics teachers, researchers, and other persons who are interested in the spreading of scientific knowledge, promotion of scientific temper and culture with a focus on improvement of quality of physics education at all levels. So to achieve efficient outreach, it has sectioned the nation into over 5 regions, that is North, South, East, West, and Central Council. Next slide, please. So these are the council members of association who is doing great job for the society. Next slide, please. So I'm humbly requesting you all, if anyone wishes to join our association to serve the nation, most welcome. Even most of the members of the AIP WhatsApp group shows interest to join AIP. So this is all about brief information of our association. Now I'm going to handle over this meeting, this talk to Dr. Kaplan. Over to you, sir.
Thank you, sir. So, as sir said, it was a very good initiative started by Dr. Sanjay Kumar Singh. So, first talk was on basics of physics. So, in that presentation, I was not present. So, this talk will be delivered by Dr. Pukram Deepak. Sorry if I pronounced wrong. So, Dr. Deepak completed his B.Sc with electronics in 2010 and his M.Sc in physics with electronics in 2013. He obtained his PhD in 2018 and completed postdoctoral research in 2021. During his studies, Dr. Deepak focused on conducting polymer-based gas sensor from his M.Sc project and radar-absorbing materials for his PhD. He developed experimental setups and high-voltage power supplies during his PhD and postdoctoral work. Currently, he is an assistant professor at IIT University, and there he is carrying out research based on uh, uh, include waste material conversion through devices for photosensing, metal oxide conducting polymers and nanocomposites, iron doped metal oxide semiconductor, and simple thermoelectric devices. He has published over 20 research papers in esteemed journals and is currently involved in teaching and mentoring students. So today we will talk about the basics of the physics and how it can help the society. And this is title of this talk is the perspective of physics. So basically, he will talk basic of the physics and how it can be used to entrepreneurship for the students. Okay, so over to the Deepak sir. You are not. Dr. Deepak, I guess your mic is muted.
Oh, sorry. Good afternoon, all. Camera qualities is not good. I'm sorry for that. So during my lecture, I will be off the camera because the slide are covered with the camera, which is not visible to the slides. So sorry for that. So so I'm going to share my slide. So is it visible?
Yes.
Yes, sir. It's visible.
So myself, Dr. Pukrambam Deepak, Assistant Professor, Department of Physics, Nanoscience Research Lab, School of Science, ITM University, Gwalior. I thank the API for giving me an opportunity to share about the experience which I have. So today's talk will be mostly focused on the perspective of physics So basically, the talk will be more for students rather than for the teaching teachers or professors or for the researchers. So I will be focused mostly on the students' perspective, and whatever I'm going to start, whatever I'm going to deliver, most of the faculties members has already come across, and those are not new for the faculty members and the research scholars. So, starting with my lecture, these are the contents, introductions, what are the opportunities in physics, entrepreneurship and physics, why do we need to study physics. So these are the four main topics that which I'm going to discuss in today's lecture. So little about the association, as already Dr. Sanjay has already briefed about the association. So I'm going to just highlight the objectives. So the objective of the API is to do for youth and young teachers of nation who is highly motivated in physics to make great nation using experimental exposed in school, colleges, and universities. So from these perspectives, everyone can join either in maybe school level, high school, college, or university, or any other who are interested in physics. So with this, I would like to ask students this few questions. That is, number one, this questions is for student. You don't need to answer. Just like to put the question. Why does dropping petrol or alcohol in our body makes it cold? Okay, the first question. Second is, why do food cook in pressure cooker cook faster? The third question is, what would happen to our civilization if the mobile phones was not invented? Then why does the food that is fed by our mother by crushing it into a fine paste have more taste? Why does the bicycle at rest fall, but if it is in motion, it does not? What is time? How it is measured? Next, why does the universe follow certain laws? Who govern these laws? So these are the questions that we can ask ourselves, or moreover, these are the questions that we experience in our everyday life. Okay, so if we try to find the answer to these questions, then definitely it will give rise to one branch of science, what we call as physics. So whatever the questions that I have written down here will be found in physical nature. Okay, in a physical phenomena, are the physical phenomenons. So trying to answer or hunting the answer of these questions will lead to a physics. So my request to all the students is that please try to watch the physical phenomena around you very carefully. So watching all those physical phenomena will lead to understanding of physics. So with this, I would like to start with the quotations from the Albert Einstein. That is, imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, simulating progress, giving birth to the evolution. It is given by the famous scientist Albert Einstein. Okay, so from here, physics. The science of physics examines the underlying laws of universe by looking at matter, energy, and their interaction. It aims to comprehend the underlying principles of force and the rules that control how the physical universe behaves. Second, physics is a qualitative and experimental science. It relies on precise measurement, mathematical modeling, and experiments to explore and explain natural phenomena. Physics encompass a wide range of concepts, including motion, forces, energy, electricity, magnetism, optics, waves, thermodynamics, quantum mechanics, and relativity. This concept provides the foundations for understanding how the physical world operates. So, next question is, when we introduce physics to every student, what we have found is that this one. Okay, everyone's scared. Okay, students are scared of it. Okay, when they heard the subject physics, they think it is a very tough. Okay, so why it is tough? Okay, there must be certain reason that why student afraid of physics. So when we introduced the subject called physics, it's like a ghost is hunting. So it is a time to ask ourselves why we are afraid of physics. We have analyzed, we have to analyze the weak points and improve those points by taking help from the teachers, guide, and the supervisor. So the reason behind that this students doesn't want to study physics, I don't mean all students. Many of them were interested in physics, but I'm talking about to those particular students who are afraid of physics. So it was due to these reasons. Number one, that is complex concept. Okay, yes, physics was complex for the students. Then another one is mathematical intensive. So in physics, only the statement or the principle does not work until and unless it was proven using the mathematical tool, as we know that physics without maths cannot be exist. Okay, so we need to understand about the mathematics. Without mathematics, the physics cannot be moved alone. Next, I will problem solving challenges. Okay, I will merge these problem solving challenges with the lack of visual representation. So understanding the question and visualization is very necessary for physics. Say if there is a question, or if you want to learn physics, you need to have a good imagination, okay, visualization, a picture in your mind. Then it would be easy for a students to learn the physics. So here it is my personal request to all the faculty members who are here, that whenever you teach the physics, please try to draw as much as you can in a blackboard the diagrams, so that the students could easily grasp the ideas. Next, perceptions difficulty. Yes, of course, understanding or not getting clear about the problems. So here I would like to request to all the teachers, please do give the examples with the surrounding around us. The last one, which is very important, it is lack of interest. Okay, so all the problems can be solved if you have interest. If you are not, it cannot be. So learning physics doesn't in that, if you it is not a vacation type study. It is a continuous study. Okay, we have started your introductions of the physics, I hope in class 6, 7, 8. Okay, it's keep on introducing up to 10 and up come up to 11, 12, and so on. So you have to have an interest in learning the things. Okay, if you are interested, then no one can oppose your no one can block or oppose your curiosity. So you should put your best level to put interest. So a requirement for learning the physics, as I have mentioned in the previous slide, number one is strong imagination. Number two, good mathematical skill, that is such as algebra, calculus, differential equations, etc. So whatever the physics that we are going to learn, we have to use mathematics. So without mathematics, physics alone, as I have said, physics alone cannot move. Okay, especially in case of theoretical physics, you need to have a very good skill of mathematics. Next, should perform experiment. Okay, performing experiment will help us understanding the laws of physics. Say, for example, in your class 10, you might done the experiment based on electricity, magnetism, then about the light. So please perform all the experiments that are available in your syllabus. So teachers should also help in performing the experiment for the students. Next is, so develop habit of watching closely to the physical phenomena. As I have stated before, we have to look the physical phenomena very closely. There are a lot of physical phenomena which are occurring around us that we have never imagined, but all those physical phenomena can lead us to understand the physics. Above all, the most important criteria is your curiosity about knowing the natural phenomena. So in today's talk, I will be mostly focused on academic as well as research, very less about the research, but I will be talking about mostly in academic. So to bring the scientific temperament, both academic as well as researcher need to be play important role. Everyone is inspired his or her life from certain incidents and get attached to physics. Here, the role of teachers and researchers comes to play. Teachers are one whom students inspire the most. Students are also inspired from the biography of the great physicists and start learning physics. Creation of interest in physics among the students, the teachers plays important roles. So you should be best teacher teaching the physics. So to become an academician or to become a researcher, or you can become both academician plus researchers. So roadmap, I will be discuss about the roadmap, how to this roadmap might be I hope maybe also discussed in the first lecture by the Ankit sir. So here, so after 10+2, you can have a diploma in education and you become a primary teacher. Okay, so why I was why I was discussing about this is the idea of science or putting the seed or knowledge of science started at the very uh, age, at the very age of the students. So primary teachers should play a very important role here, also have a very important role. So they should teach the student in a such a way that they should not afraid about the subjects. So after 10+2, you can do a diploma in education and you can go for primary school teacher, which is also one of the good option. Next one is you can go for B.Sc physics. Okay, either honors or a general courses. After that, you go for B.Ed for 2 years and you become a high school teacher. So I was giving a more emphasis on academicians in today's lecture because it is the teacher who is going to, ignite the minds. I don't mean to say that the the faculty members or the students who wish to perform or go through the research have a less importance. I don't mean that all has equally played. No, it should play equal platform. So here, after 12, you can go for B.Sc physics. Then after that, you can have a B.Ed. Then you can become a high school teacher, and you can contribute the knowledge you have learned in during these courses and imparting the knowledge to the students in a great extent, and you can impart the knowledge of physics. Next is you go for B.Sc physics B.Ed courses, 4-year degree. Okay, this course is basically available in the ISER. Okay, so there are 7 institutes, you can go there. Then after that, you can apply for the high school teachers. Next is you can go for M.Sc physics. Then you go for B.Ed. After that, you can become either you can become a high school teacher, higher secondary teacher, or a high school teacher, or vice versa. You can complete your B.Ed first. Okay, after that you can go to your M.Sc physics. From M.Sc physics, you can go through this higher secondary school. Next is 10+2. After that, you can go for B.Sc physics with integrated M.Sc. Is a integrated courses. Okay, you will be doing both M.Sc, B.Sc, and M.Sc. Then you can go for B.Ed. After that, you can become your PGT. Okay, postgraduate teacher. Or after 12, you go for B.Sc physics. Then you can apply for these 3 posts. That is technical assistant in DRDO, technical assistant in bar, and instrumentation. So technical assistant in DRDO is you should apply through exam called septum. Okay, which is a good exam. If you are selected here, then definitely you will be working as a technical assistant, and after 7 years, and if you are having your M.Sc degree, then you will be allowed to enter a departmental examination, after which you will be promoted to scientist B in DRDO. So B.Sc physics, okay, you are having a B.Sc physics, then definitely you should try this 3 job. For M.Sc physics, then this is for basically for the research and the college level or the university level. So you go for NET or SLATE. Then after that, you can become assistant professor in university or in colleges. Then you go for GATE. Then from GATE, you have to go for research. That can be done in your IITs, NITs, triple ITs, central universities, state universities, and you can become an assistant professor. Or it can be scientist at different sector. Different sector means either it might be in government sector, or either it might be in the private sector. Okay. Or after doing your PhD, you can go for postdoc either in foreign countries or India. There are good opportunities for postdoc in India. Also, there are a lot of fellowships are there. Okay, one of the fellowship that which I would like to mention here is assistant professorship. Assistant professorship. Okay, given by the DST. Okay, so DST will be you have to apply to the after PhD. You have to apply to DST for assistant professorship. Then you will be getting very handsome amount of salary, plus this assistant professorship will be last for, I hope, maybe 5 years, and around you are going to get 35 lakhs, okay, for your research. So it is 7 lakhs per year, almost. It's very good. Then another one, after doing your research PhD, you can go for another faculty. There is another one which we call as Kothari. Okay, for that also you can go, and you will be getting a good handsome amount of salary. Means you will be treated like a professor. Right. So next is regarding the research, that is experimental and theoretical. You have in experimental, that is condensed matter, nuclear, high energy, astrophysics, particle physics, nanoscience. Both are available for experimental as well as theoretical physics. So you can be, do all this after M.Sc. You can go for research. Then you can choose one of your topic from the given, or beyond this topic you can also choose, and you can go for your higher studies. So I would like to introduce here. This is the semiconductor market, okay, for the world. So in 2001, the market value is some around $600 billion. Okay, in 2001, it is some around $600 billion. And also in 2002, it is some around 600 plus billion dollar. But the expected market value for after in 2029 is some around $1,400 billion. Okay, so you might be asking that why I was introducing this market value in today's lecture. So it will be explained later on. Let us come to Indian market. So Indian market, the semiconductor market for India by 2021 is some around $23 billion, and in 2029 it is expected to be $80.3 million. Okay. So next is if you are pursuing your PhD. PhD is takes a very long time, roughly 3 to 5 years. Okay, sometimes it takes up to 6 years. But all those during those years, without financial support, you cannot perform your, you cannot go for your study. So we need some financial support during our studies. So there are fellowships that provided by the government of India, like Prime Minister Fellowship for Doctoral Research, Fulbright Nehru Doctoral Research Fellowship, Jawaharlal Nehru Memorial Fund Scholarship, Physical Research Laboratory Junior Research Fellowship, Google PhD Fellowship Indian Program, Maulana Azad National Fellowship, NCRT Doctoral Fellowship, CSIR, JRF Fellowship, and last one is Inspire Fellowship. So beyond this, there are also a lot more, but I'm just highlighting the important ones, or mostly, people applied it. So today's topic, which I would like to focus most, is physics and entrepreneur. So entrepreneur refer to the process of identifying, creating, and pursuing opportunities to develop innovation ideas into successful ventures. It involves the willingness and ability to take calculated risks, organize resources, and navigate uncertainties with the aim of creating value, making an impact, and achieving sustainable growth. So many people used to ask, what is the connection between the physics and the entrepreneurship or entrepreneur? Okay, you can become an entrepreneur using all the fundamental laws of physics that you have studied, okay, such as development of new methods for the experiment, designing new experimental circuit, designing new experiment setup for those which are still using the old method, and experiment. So innovation. Entrepreneurship is closely associated with innovation, whether it's developing a new product, service, or business model. Entrepreneurs strive to introduce something new or improve that address existing needs or create new one. Risk taking. Entrepreneur embrace calculate risks as they understand that success often requires venturing into the unknown. They are willing to invest their time, money, and efforts with the understanding that there is a possibility of failure. Okay, so in a simple sentence, uh, doing a business, okay, establishing a business, it's a very risky. Okay, it might be success or it may not be success. So there is a chances of both. Opportunities identification. Entrepreneur possess a key abilities to identify and evaluate opportunities in market. They have a lack or spot gap insufficiencies or undeserved needs and envisioning way to address them profitably. So for example, taking an account at present in material science or those who are pursuing the research, in last few days back, I have read one of the newspaper that explaining that the Indian researchers are doing less research on graphene. Okay, they used to. There's a report that Indians are doing less research on graphene-based research. Why? Because graphene is a future material. Okay, so you may ask the question, what is a graphene? A graphene is a single layer of graphite sheet. It is known as a graphene. So it's the strongest material, highly conducting, electrically highly conducting, highly thermally conducting, highly flexible. Okay, stronger than steel. So if you spread 1 gram of graphene, then it would be cover an area around 100 and 1,200 meters square area will be covered by the graphene. Okay, so graphene is a zero band gap also. So it's a future material and best quality graphene. Okay, best quality graphene of 10 gram. It may cost more than some 50,000 Indian rupees. Okay, so it has a very good scope. So we should, when we do the research also, we have to look in such a way that it will give the benefits. Resource management. Entrepreneurs are resourceful and adapt at managing the leveraging limit resource effectively. They may seek funding, build a team, establishing partnerships, and allocate resource strategically to minimize their chance of success. So proactiveness and perseverance is very necessary. I will not read out all this. Then value creation. Okay, entrepreneurship aims to create value, whether it's economic, social, or environmental. Entrepreneur strives to bring about positive changes by offering products or service that fulfill needs, job create, drive economic growth, or contribute to the societal well-being. Growth and scalability. Successful entrepreneurs envisions and pursue opportunities for growth and scalability. They aim to bring businesses that can expand and thrive, potentially reach wider market, attracting investment and creating sustainable ventures. So you might be asking that why it is very necessary about this entrepreneurship. So learning physics doesn't mean that we should only become a assistant professor, or either a researcher or a scientist. So the knowledge of physics, whatever we have learned during the courses, either in maybe your B.Sc, M.Sc, or research, PhD, you can use all those knowledge, okay, and you can start off your a company, or you can become an entrepreneur. So whatever your findings during your PhD or during your studies, maybe your B.Sc, even I can take an example from the B.Sc also. During your B.Sc, you might perform a lot of experiment, okay. So those experimental setup you can also design yourself, okay, that will become a new, okay, that will become an innovative ideas, okay. You can mostly connecting with wires and so on. You can do some banana cables, okay, then you can put it there, you can arrange the circuit, so that will become an innovative. And if you are success, then it can be again, bring up to a bigger platform, okay, in a bigger marketing value, then you can earn a good of no good numbers of amount of money. As well as, I don't mean to say that about the money, your interest of finding or creating or inventing a new experimental setup will be more and able to perform uh, in a very proper way if you have a good economic stability. So the topic here I would like to explain is, let us take an example of Raman spectroscopy. So Sir C.V. Raman, okay, won the Nobel Prize in 1930 for his work on scattering of light and discovery of the effect named after him, that what we call as Raman effect, okay, inelastic scattering of a photon. He was born in 1888 and died in 1970s. Okay, so let us see the instrument that he had used during his time. So this was the apparatus that he used. Okay, so this is a constant deviation prism. Okay, so this was the Raman sir himself, and this is the apparatus that he had used, and he got the Nobel Prize in 1930. So now what happened is, let us see how the Raman spectroscopy instruments look like. Now it is come in this form. It's a portable. Okay, you can take anywhere and you can analyze. So from this stage, it comes to this stage. Okay, the principle is not changed. Okay, the principle, the physics behind the Raman spectroscopy during the Sir C.V. Raman and at present there is no change. But the experimental setup or the experimental instruments are now innovative, okay, more reliable. So from this stage, okay, from this stage it is changed to this stage. So this is an innovation, and this is the one which Indians are manufacturing. Okay, I have doubt that India, since very long time, okay, India doesn't produce any instrument based on Raman effect to analyze for the Raman spectroscopy, which was one of the demerit for us, because Raman spectroscopy was given by an Indian, and we the Indians are not able to develop our own Raman spectroscopy. And most of the institution, okay, big institutions like IITs, NITs, then triple ITs or central universities, okay, they used to purchase this instrument from the foreign countries. What does it mean? It means that the money is drawn out of our country. So even though we give the Raman spectroscopy to the world, still we are not able to develop a good instrument for the analysis of the Raman spectroscopy. So my point here is that we
Hi,
should try our best
can,
to develop such type of.
can you hear me? Can I ask you for, like, what could be the reasons why Indians are not developing these instruments in our country? So,
Sir, I will explain later on. I'm sorry
Okay.
that I will explain later on. Okay.
okay,
It is a very interesting question, and I would like to discuss that point also. Okay, thank you for asking that, putting that questions.
okay, thanks.
So now this is the simple microscope, okay, that were invented by the Hooke. Okay, it is in 1670. It is in 1670. Now, if we are not go for the innovative ideas, or if you are not moving towards the advanced version, then we will be still at this stage. But now what we have known is this type of microscope is come to exist. We have used during our biology classes from class 6 to 10 up to 12. Now more efficient version is come out to be this one, like this. I don't mean this is exactly this one, but more efficient one is like this. So my point is that innovation is very necessary in our physics also. So the younger generation, those who are in the B.Sc student or M.Sc student, whatever the experiment that you have performed during your courses, please go through it very seriously, perform the experiment. Okay, so some of the experiment that you are going to perform during your B.Sc or M.Sc are the one who got the Nobel Prize also. Okay, say some examples like your this G-Man effect. Okay, then Stark effect. Okay, all those things are, they won the Nobel Prize. Okay, then Thomson E by M method. Okay, student used to take very lightly. Okay, when they perform the experiment, they used to think as a simple as experiment. But if you look very carefully, that those experiments are also the one who got the Nobel Prize in physics. So it is my personal request to all the students as well as to the faculty member, when you perform the experiment, please perform it as an you are doing a research on it. Okay, then it will give a new light or new test. Otherwise, if you think as a simply as an experiment, and that's not, no, it will not give a new test. So whenever you perform, you please go through it. So this is the revolution that I'm talking about. From this stage, okay, it comes to this one. From this, it goes to your electron microscope. Okay, electron microscope. It goes to electron microscope. There are different type of electron microscope are there. I will not discuss here. So this is the innovation. Likewise, the experiment that you have done in your B.Sc, you can modify it. If it is good, you can put to the market value. Next is this one. The most important thing is intellectual property and patent. So physics research often results in intellectual property which can be protected through patents. So for example, you have a new finding. Those findings you can be patented. Okay, you can protect it from copying by the other. So likewise, any student, okay, any student who are performing the experiment in your lab or the researcher, please do it very carefully and try to innovate it and try to get patent. Okay, so here with the Indians, some people used to say that jugaad, okay, कि जुगाड़ से काम चलता है. But those jugaad that which we have used to perform the experiment, some jugaad are quite good. Okay, they are feasible, they are economically profitable. So design, modified, and patented. So what are the benefits of patent? That is, number one, avoid invention theft that no one can copy. Okay, higher profit margin, reduce competition, encourage settlement, market share expansion. So whatever you have done, it might be a small, maybe a big. If it is a new and it is very helpful, it is my request to the students who are listening to today's lecture, please go for a patent. And if it is required, we will be organizing one more lecture for patent, how to file a patent, how to write a patent, and so on. So even I am going to file these 4 patents this year. Replacement of the graphite pencil lead from the waste material, carbon materials, generations of hydrogen from the environmental polluting substance, a reactor for synthesizing of graphene, electrochemical synthesis of graphene using metal salt. These are the 4 patents that I'm going to file this year. So why can't you? So now physics is associated can be associated in different branches of sciences: environmental, engineering, technology and electronics, energy production, material science, medicine and healthcare, astronomy, and space exploration. Okay, so here I would like to talk about the medicine and the healthcare. So few years back we have a pandemic. Okay, few years back we have a pandemic. So during that pandemic, we used to perform certain type of tests. Okay, ART, another one is rapid action test, something like that. Another one is PCR. Okay, so PCR, that is a polymer chain reaction, in order to identify the coronavirus, either the person is infected with corona or virus or not. We used to run for PCR test. Okay, that PCR test is basically nothing but is used in spectroscopy. Okay, because every molecules has their certain signature. Okay, so that signature, that protein was captured. Okay, protein will be doing putting in some sort of a laser beam. It will emit some light or absorb some light. Accordingly, it will give out some colors or maybe some energies. Okay, by analyzing all those things, we can identify that whether the person is infected with the coronavirus or not. So that in PCR is mainly working for the spectroscopy technique. Okay, there is a replication, then what to say, reproductions of the large amount of cell from one single cell to large amount of protein. That's another biological term. But at the end, analysis part is spectroscopic technique. So physics is everywhere. Lastly, I would like to talk about the forensic science. Okay, we might think that, oh, what is the relations between the forensic science and the physics? Yes, there is a big relations between the physics and the forensic science. In forensic science, there are certain topics like forensic microscopy, forensic spectroscopy, then ballistic physics. Okay, so without knowledge of physics, it can't be. Say, for example, you might heard about the gunshot residue. Okay, then you might talk about why the bullet are spinning. So coming out of the barrel, why the bullet are spinning and why it has to be spin. So all those things comes plays with the physics. So lastly, my question is, why do we need to study physics? I hope everyone might got the answer to all the lectures that I have been delivered today, to all the slides that which I have delivered to all of you. So my suggestions or request to the whole audience is that you should have weekly, monthly, and yearly target. Okay, small achievements makes big achievements at the end of the months and the year. So please try to read the standard books. This is to request to the students. Okay, so regarding your target, say for example, this year I'm planning to file 4 patents. Okay, maybe next year I might be target for 2 patents with 3 papers and so on. So please, everyone should have a weekly as well as monthly target. Okay, and analyze yourself at the end of the week, at the end of the month, at the end of the year, whether you are able to achieve all those things or not. Okay, if you are achieved, you will get it is very good. Otherwise, you have to put a target so that you could achieve all those things. Lastly, I will request all the students to read these 3 books: Quantum Mechanics, The Theoretical Minimum by Leonardo Susskind. Okay, so Leonardo Susskind is a theoretical physicist from Stanford University. He is also known as the second Einstein, and he was the person who introduced the string theory, I hope. So please go through the 3 books. These books doesn't have hard mathematics. Okay, very simple mathematics are there, so everyone can go through it. You please go through this book like reading like a novel. Next, for the love of physics, Walter Lewis, one of the finest teacher who taught physics in YouTube. He is a retired professor from MIT. Then the last one is the Theory of Everything, Stephen Hawkins. Please go through these books. You will get a lot of information about the universe, about the physics. So, taking today's opportunities, I would like to introduce my university. That is ITM University has the facility of UV visible spectroscopy, Fourier transformation infrared risk spectroscopy, photoluminescence spectroscopy, scanning electron microscopy, and atomic force microscopy will be available very soon. So I request all the faculty members and researchers, you can send your samples and we can collaboratively we can I can help you. So there are some homegrown facilities in ITM universities which I personally developed: spray pyrolysis, thermo EMF measuring setup for thin film, then photosensing. For photosensing, we are able to measure up to microampere. Now we are going to develop for measuring the nanoamperes, then reactor for synthesizing graphene, and at present it is progress for project in progress for the thermal conductivity measurement of a solid, not for the liquid. Then the ITM University's nanoscience lab is performing research in thin film deposition for gas sensor, photosensing, thermoelectric application, wastewater treatment like removal of dye, degradation, chemical decontamination, etc. Then the last one is waste material to economic value material using nanotechnology. So thank you all for spending your valuable times with the association. Once again, thank you all.
Thank you, Dr. Deepak, for very nice talk, and it was very informative and motivating talk. So now session is open for question and answers.
Sir, may I ask?
Yeah.
Yes.
Hello, sir. Thank you. Firstly, thank you for this enlightening session. I got a lot of information with which I can enlighten my students to pursue their careers in physics. Moreover, the question that I have is that I have done M.Sc physics. I'm teaching grade 11 and 12. I want to pursue PhD, and I want to do it in part-time mode. So please tell me, can I go for private universities that are nearby? On what basis should I choose? Because I'm a little skeptical with this thought that maybe it's just for fundraising, or is it going to be fruitful also? I want to do good research. So that's my question. Please guide me.
Basic. Okay. Before that, I would like to ask you, put one more questions to you. Whether you like to go to purely teaching or doing research with as rest of the peoples are doing their research.
Sir, I'm a family person right now, so I can't leave my job. So I would be preferring to go for part-time PhD.
No. I know, I got it. Either it's a part-time or full-time. This is not an issue. Okay, fine. What I would like to suggest is that uh, uh, physics, you can go for PhD in physics either in a part-time or either in a full mode. So here, what I would like to suggest is that you can go for the um, for the teaching methodology. Okay, as you are in a grade 11 and 12 pieces, I personally suggest you should go for the research methodology. Okay, sorry, not research, teaching methodology. There are a lot of uh, institutes are there, okay, which are available for part-time as well as the full-time. But my suggestion to you is that you can go for the teaching methodology. It's a good scope.
But sir, teaching methodology, PhD in teaching methodology, I believe it would require MEd.
No,
And
no, no, it's not required. You can do it. There are a lot of opportunities are there. Even the Tata Institute of Fundamental Science there is also one section that which they go for the methodology only. But otherwise, if you want to go for the as the rest of the others are doing, you can also go through it, no issue. And regarding the part-time, I would like to suggest one of the universities in Arunachal Pradesh, what we call as NERIST. They open both for full-time as well as part-time, and this is one of the good institution from top running institution in Northeast India.
And will it be providing in distance mode? I'm a
Yeah. Definitely, they will be providing the
PhD in
distance.
distance mode.
Yeah,
Okay.
yeah.
Okay. And so there's no point, when I have to choose a university, like I'll be choosing private universities. So should there be any criteria, or should I can trust them, right?
Yeah, you
That's
should go for the good private universities, and you can go for the good private university, no problem. So Aradhana ma'am, I would like to talk you regarding this personally. I don't like to disclose all those things in the public domain. You can text me. I will give you more information.
okay. Sure. Would you be provide? Okay, I'll be doing that. Okay, sir. Thank you.
Okay. So during
Just one suggestion from my side. PhD in the part-time mode, but you want to leave your job, right? So may I ask, like, is there any reason why don't you want to leave your job? If it is just because you're a family person and you need money, so while doing PhD, you will also get money, right? And sometimes while doing PhD, you will get money which might be quite comparable to your doing a teaching, and you are getting that money. So it is not always very fruitful to do fantastic research in part-time mode, because this way you have quite a limited resources available, because you do not have always access to the university network to 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 get all the resources from the network, like all research articles and so. And the second thing, like, you do not have a very regular physical contact with your supervisor. So this actually differs quite a lot, and sometimes I really know that the PhD doing in a part-time mode may take 8 to 10 years, and here there are a lot of people, and they witness that PhD doing in a part-time mode may results. There is a quite a high chance, very very high chance compared to PhD in regular mode, that you will be ending up leaving the PhD. Believe me, this is the case. And here there are a lot of people, they all know that PhD doing it in a distance mode is not very fruitful. Like, anybody, I'm open for anybody who know that people.
Okay.
Yes.
Okay. So it depends on what is your area of interest. So people do PhD in part-time mode. So like one person I know very well, he was my senior. He did PhD in theoretical high energy physics. He was a manager in Broadcom Communication, Bangalore. He was doing full-time job, and he was doing part-time job PhD, and he did very good work, like 7 or 8 paper he has published. So this depends on your interest. If you're really interested in physics, you're not doing it for money, then you can do part-time or full-time, doesn't matter. But if you're doing experimental PhD in experimental physics, then you cannot do part-time, I guess, because then you have to visit the experimental facility and perform all the experiments. Then it will be difficult. So there are many places in India who offer part-time PhD, but in part-time PhD, you won't get any money, or you get money only if you have full-time PhD.
Thank you.
Yes.
Thank you for guiding me.
I would like to add few points here. Radhana ma'am, as you asked, what should be the criteria for choosing the college or university for doing the PhD? The first criteria should be the researcher facility. Whether you want to do theoretical physics, PhD in theoretical physics or experimental physics, you should look for the research facility are available there or not. On the basis of that, you can choose. And second point should be the nature of the supervisor. How is your supervisor? You can ask the pass out student of his or her. Based upon these 2 points, you can choose the university.
Thank you, sir. Thank you, Om sir, and thank you, the other sir, supervisor sir. Thank you.
So one of the question that was asked during my lecture regarding that why the Indians are not developing the instrumentation.
Yes.
So yeah,
Yes.
it's a very big question. Okay, to be frank, I don't know why they are. To be frank, I don't know whether they are not interested or maybe lack of facilities or lack of fund. But I hope we can also develop the same. So I
No.
forget one of the professor from the IIT Kanpur. He quit his job and he developed a microscope known as STM, scanning tunneling microscope, and he was success. But regarding the Raman and others, Indians are not developing good, instruments. But there is, I will not be blaming to the companies or the instrumentation who are producing the instrumentation facilities. I would like to give the responsibility to both the academic as well as the manufacturer. If the Indians are not buying their own product, then the amount of income that would be generated, it will be very less. So like, Indians start buying their own product, defense product like Tesas and Brahmos, blah, blah. Likewise, we should also, focus on buying the instrument from our inside. But being said that, if the quality of the instrument is no doesn't meet our requirement, then it is not again useful to us. In that case, we have to go beyond. So even the CV Raman sir spoke about that we should try to perform the experiment by building our own instrument. So he even object buying an instrument from the foreign countries. So I don't
Sir,
mean that we should not buy. We should buy definitely, but we should try our best to develop some of the experimental setup that which we could develop.
here are my question. Like, the questions like you shown in your institute and in your laboratory, you with spectroscopy, Fourier transform spectroscopy, and so these things did you made by your hand?
No, they are just bought from some others.
Yes. So did you try investigating why did they bought and why didn't they made from the hand, or why didn't you made it from your hand?
Okay, to answer your question, I will be showing one slide that will
Uh-huh.
give you
Please.
more profitable.
Mm-hmm.
Uh, have you seen this this slide?
Just show.
So homegrown facilities in ITM universities.
Yes, these are
Okay.
spray and tabletop
So
facilities.
spray paralysis, if you buy from the market, it will cost nearly 2 to 3 lakhs, the
Yes.
most cheap one. Okay.
Mm-hmm.
Then thermo EMF measuring setup. Okay, it is very costly. It costs more than 1 crore. Okay.
Mm-hmm.
You can measure this thermo EMF in India in IIT Roorkee, and it is not open for the external universities. They are using for the internal, and for characterization, it is for one simple characterization is cost more than 6,000.
Sir,
Wait,
I
wait, wait, wait.
understand.
I will answer your question.
Mm-hmm.
Next, regarding the photo sensor. Okay.
Mm-hmm.
In order to measure the photos current, you need to use Kitley and so on.
Mm-hmm.
So that costs nearly 2 lakhs to 3 lakhs.
Mm-hmm.
Similarly, the thermal conductivity. So what I mean to say is that all these instruments are set up by myself with the help of my
Mm-hmm.
PhD students, that which
Okay.
are working good well. So what I mean to say is that there are certain things that which I may not be able to develop, like as you have mentioned, UV visible, Fourier, photoluminescence, and so on. So what I want to say is that whatever we can develop, it has to be developed with our own hand, and we have
Mm-hmm.
to perform the experiment.
Yes. So, sir, my comment is here. What? Uh, So while doing these things, like so actually this is not my actual specialization, but I might tell you like why people are buying and why they are not developing. So here is the thing. First thing, like when you buy a UV visible setup, what do you want? Like it depends, like which kind of UV visible spectroscopy you want to do. If it is just a sample chamber and just a laser or something, and just a spectrometer, a small spectrometer, it might be an Turner spectrometer. So it costs around in Indian rupees, cost around 20 lakh rupees. Okay.
Yeah, definitely.
Yes.
It's very costly.
Yes, I understand. But when you go for making it by your hand, first, the very first thing you want an optical bench. Okay, optical bench,
Yeah. We need
a
the
good
optical
optical
bench.
bench which has a like air facility and all this stuff. It costs around 50 lakh rupees. Okay, now you
Mhm.
now you need some mounts. Okay, simple mounts with ultra low expensive material, you can make them in your workshop, but however
Yeah.
it depends like how
Mhm.
your workshop is. But then comes these mounts, optical mounts, and one
Mhm.
mount costs around 300 euro.
Mhm. So
At
all
least
those are buying from the foreign countries.
yes, so like these Thor
So,
labs and all
so
this
what I
stuff.
would like to answer, I would like to say is that if you can, design yourself, then I hope we should design it, if it is
Okay.
possible. Okay, if it is possible.
uh,
So
uh,
we should also, encourage our Indian manufacturers. Okay, so that all those problems will be solved. Okay, so I hope like you and me, we can work together, and we can sort something. Even though we are not able to invent or manufacture a big one, we can start small. Start it from a small things. I hope we might need to talk personally, and we can work together, and we can develop it. You have a good knowledge about it.
like I do
Okay,
spectroscopy, but
there are many
but
other people who are reading have their questions, so you may have
Okay,
discussion.
Captain. So I'm really sorry, but I was just asking like
So
why are
yeah,
we not doing?
yeah,
Because some
okay.
labs in India really do it. I know some labs in India, any type of spectroscopy, they take 1 month, and at least if it is invisible range, they take 1 month and they develop. But
Yeah.
some labs are not
Thank you for the
doing.
question.
Bilkul. Yes, you are right, sir.
Yeah. Pratibha Bharadwaj, you have questions? You have raised your hand. You may ask. Pratibha Bharadwaj.
Sir, there is one question in chat
Yeah,
box that raised
Yes,
by
sir.
Savita Sharma.
yeah, yeah.
Hello,
Pratibha is
sir.
there. Yeah, you
Yes,
may
sir.
ask.
I have a question. So, what is the importance to publish more research paper as a point of view of career?
Basically, it doesn't require to publish a lot of paper. Okay, try to publish a quality paper in a Q1 journal. That's all.
Okay, sir. Thank you.
Yeah, Ankit, you were. Okay, yeah, there are some
Yes,
questions. Yeah.
there is one earlier question from Savita Sharma. Sir, I'm reading his question. Her question is:
Okay.
one can join ISRO after B.Sc?
Regarding the ISRO B.Sc, you can go for the technical assistant. There is an exam. Every year they conduct their own exam. So I hope you can go there. But the best way is if you go with your M.Sc, that will be the best.
Okay. So Balaji, you have raised your hand. Wrong.
So one of the
Yeah,
students, Anirudh Singh, is asking. Anirudh is
yeah.
asking that, sir, I just want to ask that that we do have cutting edge facilities in India, then also we don't got any Nobel Prize in pure physics. It's a very good question, but still I have no answer. I don't know.
Yeah, because I guess getting a technology doesn't mean that we should get the Nobel Prize. So the novelty of the
Yes.
work. It's not
Sir,
the
I
novelty
have
of the work, not the that
Depends
is
a
that
lot.
is fine.
sir, I would just like
We have
to
to
say
go
that
for groundbreaking work.
Yeah.
uh, got Nobel Prize just with the apparatus of like 350 rupees.
Yes, but it requires a lot of work. Not
Actually, regarding this, I would like to say there are certain, physical phenomena are there. If we
Mm-hmm.
can crack it, those physical phenomena, we can then definitely uh, one of us might get the Nobel Prize.
Thank you, sir. Thank you.
but just something very interesting, that if your experiment work in your laboratory after a lot of work, then this happiness is better than getting a Nobel Prize. So believe me, you are working for 20 hours and your experiment start working. This happiness is quite a lot compared to those
What you get.
who get the
Yeah.
working hour. I work with Anton, and he's like the most fantastic moments in my life wasn't getting a Nobel Prize, but when my EPR experiment was working, I get more fascinated with this.
Yeah.
I agree with the Tripathi sir. Yeah, that's
Uh,
happened to me. So last year, maybe 2001 or maybe 2000 or 2001, I try, my best to measure some of the physical parameters. I was trying to measure with my apparatus that which I have developed in my lab. So it takes nearly 4 months. After 4 months, I know how to measure it. So when the day when I come to know the techniques to measure, it was, it's a very joyful. I was happy very much. So there is also another question raised by the Balaji Z. Does M.Sc physics with NET GRF along with NET GRF is sufficient to enter central universities as assistant professor? Yes, you can. But after that, you have to do after entering, after getting, after selection, you have to go for PhD again. You cannot stay only with the M.Sc or NET GRF.
is there any cause like in the country of ramen, very people are doing ramen, you know? I know a lot of people are doing Raman spectroscopy and so, but in the country of Bose, no, very small people are doing Bose-Einstein condensate related physics, mainly experimental physics.
Yeah, people have done, I guess, Bose condensation, superconducting phase, and all those. But we work.
I know people have done, but like
Yeah.
have done and
So,
doing physics with them, you know.
so like it is
Getting
not only related to condensation, like Bose, what he has given that is application is very large. Okay, so from high energy to low energy, everywhere we use this Bose statistics. So that is very important.
I know, but there are only two
So
laboratories
like even
in India.
Higgs. No, a single part is fine. That is what I'm saying. There's his theoretical way taking by the whole world, like Higgs boson. There is also a boson. There's also calling a boson actually state. Right?
No,
Boson
Higgs boson is not Bose-Einstein state. It is a boson. Bose-Einstein condensate is like you
condensate
could.
is state. Condensate is state. I'm saying state is this. Okay, like
Yes,
MT and FT.
statistics. Yes, they
Right.
follow.
Fermi beyond Fermi statistics like BE or MB. Okay, so in that sense. So what he has said that is the both statistics. It has certain properties which can be applied in experimental parts like superconducting phase and all. Right? Yeah, so still working on that.
No, but why it is important? I assume that's something like people do a lot of theoretical research papers, a very lot in any field. Let's say condensed matter field or for the graphene and for the many things, electronics and so. But after doing the theoretical research, how do you know that this theoretical research is correct?
Okay. First,
Yeah.
either you provide some theory, okay, then there is followed by
Yes.
some experimental evidence. Like
That-
you know,
that-
string theory, like string theory. So it is pure theory, mathematical models, okay. But what is the only flaw or drawback, that there is no experimental evidence of the string theory. So that's where it is lacking. Okay. So if you provide something theory, so like speed of light, it was first posed by a theoretician. Okay. Then later it's got discovered. Okay, measured. Okay, or tracked. Okay, this is speed of light. So Maxwell who said that the speed of light is 3 to the power 8 by simply using the permittivity and permeability combination, right? So theory, so one need to provide some theory, then experiment can work. So in what you think you need some base to work on, na? To discuss what we need to achieve. There should be something. So you need some idea. That idea is theory. That idea is theory. There is no difference in theory and experiments. The idea which come in your mind, that what should I do? That idea is theory. Yes.
Yes, sir. Sir, why I'm saying this? There is a
I think,
logic
sir, we
behind
should
it.
conclude the event. It is getting very late. All the participants are waiting.
Oh, so
We can do the discussion later on individually.
what is the time, by the way? 3.
It's 4:30 p.m.
More than 1 hour.
I'm really sorry. I'm not in India, so I'm
No.
really sorry. But a very small thing. What I want to conclude, that if you have this Bose-Einstein condensate or ultra cold gases, they're one of the in their purest form in ground state, and then you can make a optical lattice with it, and you can simulate any theoretical phenomenon experiment, like let's say graphene lattice or hexagonal lattice, triangular lattice, superconductivity, or anything you can simulate, and then you can say, okay, my theoretical research is this, and this is my experimental result. Most of the time, what really happens, even in very standard model like Howard or Felikov-Campbell model, that this external environmental perturbations are so high that theoretical research, they have like very, very, very high difference from the what experiments gives. So for simulations of all these things, I think like these laboratories which involve like laser cooling, trapping, condensates, lattices, they are really, really important, and it's only possible when you have hands-on experiment, that as it was like initiated from the top, like hands-on
Hello.
on experiment
Sorry to
building.
interrupt.
Yes.
Sorry, sir. Sorry, sir. We are getting late, so we have to conclude this session.
Darshit, you are the
yes.
organizer. Hi, how are you?
I am fine, sir. So may I request you all to please switch on your camera so we can take the screenshot, and then we can conclude the session.
Why camera is needed? I really do not understand.
For the
It's
group
just for the
photo, sir.
memory, sir.
Good afternoon, sir.
Memory, sir.
Okay.
Like those who are sleeping, how they will turn their camera on. Hello. Today was Sunday.
Yes.
I didn't even take any
Yeah.
bath, you know.
Uh, now I would like to invite Professor Ankit for the concluding the remarks, and over to you, Ankit, sir.
Good evening, everyone. Myself, Ankit. I am president of Northern Council, and I am here to present vote of thanks and conclude the event. First, Dr. Darshit started the event, and further, Dr. Sanjay sir, who is the also founder president of AIP, given an introductory speech on Association of Indian Physicists and highlighted the main objective. And later on, Dr. Captain introduced our today's speaker. And after that, Dr. P. Deepak who is also Vice President of Northern Central Council, given a talk on Prospective of Physics and highlighted the daily use of physics. He also informed about the how student can pursue career in physics. And later on, there was a deep discussion on these topics. And after discussion, we have concluded the event. I would like to thanks all the organizing and today's speaker and our founder president Dr. Sanjay sir for this the success of this event. Thank you, sir. Over to
Thank you
you,
all.
Dasit sir.
So I think we have witnessed a bit more intense discussion over the physics here between Om sir and the speaker. So this is the physics. We can debate on, carry on to 2 hours and hours, and we will get the fruitful answers. So hope to meet you all in the next event, which will be coming on the next Sunday. So happy physicsing all.
And might be, if anybody interested, we are also teaching quantum field theory course Sunday from 5. And if anybody is interested, you can join.
Okay, you can share your course link in our group, and if people is interested in the quantum field theory, they will probably join you. Today is the class. Today is your class.
No, today is not today.
Okay. So that's all from my side. Thank you all.
Thanks. See you, Darshit.
See you. Bye, ma'am. Thank you, speaker. Thank you, sirs.
Okay. Thank you.
Should we end? Sanjay sir.
Your mic is off.
Sanjay sir, please unmute.
Yeah, we can end the session. Thank you, Om sir, to join from outside India. We are very grateful. Thanks, Dr. Captain, Professor Ankit, and Professor Deepak sir, B.Sc sir. Thank you all.
Thank you.